Hey there. Um, this is going to be dated anyway, but today is March 22nd, Tuesday. It's pretty early in the morning, but yeah, no, I'd be up late early. Um, I like to work in the off times. So, oh shit. Sorry, I'm just fixing my blankie because yeah, we're going to talk about it. Fix that light. Okay. All right, better. So I wanted to describe to you guys today why my path in engineering is a bit different from other people's, from other engineers that you might be familiar with. Okay, I'm just gonna break it down. So if you've kind of been here, I'm gonna say here because this is I'm uploading this directly to my YouTube channel, but in the middle of 2021, from the beginning of 2021 to about the middle of 2021 till about May, I was uploading videos directly to my Facebook page, my personal Facebook page, because I have a professional Facebook page as well. That's not the one I'm talking about. My personal Facebook page to like a select group of friends. I was uploading these vlogs. I think I've uploaded them to YouTube at this point, so you could go back and find them. But I was uploading almost daily, like these hour vlogs that were talking about my research journey in meta learning, right? Because meta learning is the specific sector of artificial intelligence that I personally am interested in, because I personally am interested in building recommendation engines that help people learn how to comprehend what they're reading. That is interesting to me because of my passion for literacy. So, like when I worked with Robinhood, I worked specifically on the literacy sprint. That was the sprint that I was the leader of. But when it came down to project selection, the literacy project was not selected because that was a process that where everyone had to vote. Now, my project did not get the maximum number of votes. So, for the duration of the program fellowship, I did not work on the literacy app. But that doesn't change like my interest in the field of literacy or the reasons why I care and study meta learning for what it is. Okay. So, we're backtracking though, because in this video, I'm just trying to tell you the story of how I got there, how I got here to meta learning. So, the reason that I came into building and engineering, software engineering specifically, is because I was a pre-medical student at university. So we'll just say I was like at the University of California, Davis, thinking about going to medical school. And I did a summer research internship where I was working in a metabolomics lab. And the principal investigator or PI that I was working with gave me a project that I felt could be better handled with big data software tools on the computer, but he was asking me to do this by hand. So, some of the things now I was reading today that Demis Habis is now building a new lab that is working on protein synthesis. If you look at the work that they're doing or that DeepMind has done in terms of like predicting proteins, that's basically what I was doing back then, but I was just doing it by hand. Um, and I guess to even make it more clear, like for people who aren't in uh, biochem and don't understand how that translates to real world products, in terms of the lab that I was working with, they were just trying to make a bar, like a nutrition food bar. Think of like a Cliff bar, right? So it's like a food bar that had all the nutrients that you would need for one day. Not all the calories, just all the nutrients. If you don't know about the difference between calories and nutrients, go look that up. But nutrients are these like proteins basically, and phytochemicals that your cells need to reproduce themselves. Calories just have to do with like energy, and you just like need energy to actually kick those biological processes off. But if you don't have the phytochemicals or phytonutrients in your body, then you can't do the processes. So you need both calories and nutrients. That's why people always talk about the caloric deficit, like 2,000 calories is like what you need for a day. Then there's another thing about the nutrients. They're both important. Anyway, so yeah, I was really stressed out after that internship was over, because I was like, this should be done by a computer. And I was like, yo, I'm trying to go to medical school and do research, but I'm not going to do my next project by hand. So I need to go get some skills where I learn how to use the computer basically to build some stuff, because I'm not doing this by hand for another summer. I was pissed, right? So that's why I changed my major in college to computer science. And at that point, I didn't know anything about computer science, about engineering. I'd never taken an engineering class. I knew nothing about the web, the internet, nothing. So I took like one basic computer science class, and it was hella confusing. I was like, what the fuck are they talking about? It was like functions and variables and loops. And I was like, oh, hell no, this is like super confusing. I was lost, girl. I didn't know what they were talking about. Anyway, so then I can't remember how I found the resource. I think somebody posted some information on like LinkedIn or something. And I learned about a software engineering bootcamp that had like a scholarship attached for people of color. So it was like one of those initiatives, like, we're trying to get people of color into tech. We'll pay for you to go do a boot camp. So I did it was a web development boot camp called Dev Boot Camp, and it was just about building full stack CRUD applications. A CRUD application is just like create, read, update, delete. So basically you have a database. Let's make it hella simple. Like, you're going to make a web application where you buy lipsticks, right? So you want to be able to add lipsticks to the site. You want to be able to delete lipsticks once you're not selling them anymore. You want to be able to update the number of lipsticks in your inventory, and then you want to be able to see the lipsticks that you have in the inventory. Create, read, update, delete. That's a CRUD app. Most of the shit that you're doing on the web is like CRUD. So I was using like Ruby on Rails, which is like this full stack web development framework. So the language is Ruby. Rails is like the infrastructure that puts the CRUD app together. I just built a whole bunch of CRUD apps in that development bootcamp. But a part of that experience for me was I was working on teams building these CRUD apps, and I really enjoyed designing the database. So the database, relational databases are like another topic in software engineering. I just took a real passion, interest toward designing the database. And we had this thing called like labs, where every week we would go and we had mentorship and tutoring hours with software engineers already working in industry. And I matched with one of the mentors that I worked with a few weeks in a row, happened to be a data engineer at a financial tech company called Adipar. So I would just bring all of my questions about the database concepts that I was learning to him, and we would just spend the whole 2 hours talking about that. So maybe it was that really like, pushed me toward data engineering, which is where I ended up spending most of my time. But yeah, so this is why if you go look at my GitHub, you will see so many examples of entity relational diagrams or databases, because I was just designing schemas to like put all the data together, to understand what data we needed to collect, to understand where that data would go. Now, designing the database in a regular relational database for a general CRUD app that students use is one thing. It's cute. That skill is cute for a startup. But quickly I moved into corporate America, okay? And the thing about like corporate America and corporate data for companies like Facebook or Intuit, which are the companies that I worked for, and Intel, all of those companies have what's known as like big data. The thing that's different with like some database that you can store on your local machine for a web app or something in an Excel sheet is like, man, I mean, we'd have to get into like sharding and parallel processing. How do you, it basically like, as you have more and more and more and more data, you can't just store that data on one machine and you can't just access it in one call. That's like the big idea. When you have data on the level of Facebook and Intel and Intuit, the data is in multiple places. They split it up by categories. And when you're actually trying to do something meaningful with that data, you need to like pull data from multiple categories together. And in order to do that, you basically have to do something known as like scheduling. So you have to like state exactly which data you want. So you need to understand the schema or the name of the entities or columns that you want to pull from. You need to do like a cleaning process where you make sure that the way that you're joining the data is actually aligned and the formatting of the data is in whatever, whatever format you need it to be in. So you need numbers to be numbers if you need to use them in formulas, and you need, booleans to be actually true or false if you need to be able to query them in a certain way. And you have to like double check all of that stuff. And then you have to also understand sometimes you're going to get no data or null records where you actually need records, and you need to come up with a solution for that and make sure that the columns that you believe that you're pulling from, you are actually pulling from. So it's more about like validation checking, saying like, oh, okay, this is the act. Like if you need to pull purple crayons, data on purple crayons from the database, if you query something that you believe is purple crayons and when you look at it, it's actually blue crayons, then you need to like dump the blue crayon data or put it back and go figure out where the purple crayon data is and why your assumption was wrong about the first query that you made for the purple crayon data. That is a really strange, like, maybe example, but it makes sense. So maybe think about it if you need to. Anyway, yeah. So companies like Facebook, for instance, everybody, you know how many people in the globe use Facebook? It's a lot, right? Like everybody. And then also, if you think about a company like that, so it's called Meta now, but Meta owns like Instagram, the platform, the web platform, WhatsApp. All those are like working groups within the company, and all of those have data that can be queried and joined together in order to make some meaningful relationship. And that's what the job of like a data engineer does internally there. So you just pull data from different warehouses or working groups together, and then you basically make charts, tables, graphs, to show to whoever your product manager is, like whatever it is that they're looking for. Though, like a product manager will come to you with a question, and they'll be like, how many people liked posts about puppies on Tuesday? Then you'll go find and gather that data. Then you'll make a little chart and show it. It's basically what a data engineer does, kind of. That's a very simplified way of saying it, but that's the big idea. Now, in a company like Facebook and Google, well, actually, no, Facebook hasn't done this, but Amazon has. So cloud services in my time, from going from like a software engineer to a data engineer, cloud services were emerging. The big idea with cloud services is that like all these companies, these startups are growing into data first companies, and they want to collect more and more data, but they don't want to manage the infrastructure for data engineering virtually. So they want to move all of their data storage into the cloud and have another company basically manage that storage. And they want to be able to schedule jobs or maintain data engineering services using those like cloud platforms to get their data in a way that they need it. So like they want to basically move all of their data from, let's say this is an iPad, right? I want to push all the data, the movies and the pictures and stuff, the songs. I don't want it on my iPad anymore. I want to push it into my Google Drive, right? So that's like a cloud service. I want to move it all there. But then you know how in the Google Drive you have like folders inside of folders, all the folders are labeled, and then you can like use the search bar to like go find a folder in a folder, and then you can have Google Documents, Google Sheets, Google Slides, movies, pictures, all of that is available in the cloud. The first step though is putting everything into the drive, and then once it's all in the drive, you yourself as like the manager of your drive account can query it in whatever ways to find whatever data that you need. That's the big idea around cloud services for enterprise companies. So that is like sort of the problem, at least for me when I worked with Microsoft, that I started to understand, because it was very hard for me in my mind to understand like what B2B was, so business to business relationships in terms of software as a service or SaaS. So I was under the impression, I don't know, that basically with a company like Microsoft, people were just buying Excel. I was like, yeah, all the customers, they just buy Microsoft Excel for like $50 and they download it and then that's it. No, not really. Like companies like Costco, right? If you know about Costco as a company, think about all the shit that they sell in the store. So they have inventory. They keep inventory of, first of all the items in their warehouse. But then there's also an entire supply chain. So that's like shit coming into the store, different manufacturers. One manufacturer might have 5 products that are coming into the store, and there's a time frame on that because seasonally products move in and products move out, and that happens with every single manufacturer. And then there's also the whole supply chain part, when do things get from the distributor like into a physical store, and then which physical store actually get which items. Like let's say there's a manufacturer who ships from wherever to Texas, that one item, but they're not willing to ship anywhere else. Now it's Costco's responsibility to ship that product from the Texas warehouse to all of the other locations across the United States. And so all of that entire process has data and metadata affiliated with it that needs to be tracked. And because Costco has so many stores and such a large supply chain and so many products, that's actually a lot of data, and all of that they're using Azure Cloud. So in terms of like Costco as a customer, it's not necessarily just one account. You have to think about like every single store that Costco operates. It's like Costco is maybe like the parent account, but it has all these like sub accounts for every, and they might have like regions, right? So Costco West, Costco North, Costco East, and then all the stores within that region whose data are operating under that chain. And then there might be like a top level account manager who wants stats and analytics on or access to all the data for all the regions in all of the stores for the parent company, if that's what they want, because it is their data, right? So if you're thinking about or if you're trying to understand how enterprise customers work B2B with SaaS companies like a Costco and a Microsoft, hopefully that kind of like paints a picture there, and how just simply understanding CRUD apps would not be that useful in understanding like how to do B2B software as a service, big data sales or operations in corporate America. So the same problem that I just identified with Costco and Microsoft is the problem that every company has. So like when I worked with the New York Times, they were moving their data on-prem, or they had a warehouse with a whole bunch of physical servers, and they were moving their data from that into the cloud, but they were using Google Cloud Services or GCP. So there's like three major cloud providers. You have like AWS, that's Amazon's, you have GCP, that's Google's, and then you have Azure, that's like Microsoft. So there's also IBM Watson, but it's not like a huge player right now. Excuse me. And all of the smaller players, like a lot of startups, use AWS because AWS gives out a lot of credits, but their infrastructure is not as well maintained as Microsoft Azure. So from what I personally have seen internally, companies are moving, once they move from a smaller startup to like a mid-sized startup in terms of cloud data. So I saw a company like JetBlue go through this, and all of these testimonials or customer experiences are detailed on the Microsoft website. They have like a customer success website where you can read about these trials and these experiences for yourself, where they moved from Amazon to Azure as they grew. Now, like I said, a lot of those experiences for me were just jobs, and so I didn't really have any passion for financial tech. But because one of like the second internship that I got was with Intuit, and that was a financial tech company, because I was working with financial transactions, I just knew a lot about the industry because that was the type of data I was working with. Also, the first project that I worked on was called Pocketboard, and that was a fintech product where we were bringing in data on stocks. So it was like a Tinder swipe app where you can like select stocks. There's kind of a lot of apps that do that now. I guess like you can do that in Robinhood. You can actually do it in Cash App now. You can do it like everywhere. You can buy stocks anywhere now. But yeah, that was the big idea. And so working with financial transactions and financial data sets, you just start to understand a little bit more. You understand a lot about what stakeholders or product owners care about in terms of financial data sets. And every company has an accounting department or like a billing department where they're doing some sort of like analytics. So I want to just stop here for a second, because if you've kind of followed me thus far, I do hope some things make sense, like cloud computing, financial tech, and data engineering very generally as a field. But also, this has, because of like where we are now as an industry, and because basically every company now has a back end that's using one of the cloud services. So it could be AWS, Azure, or GCP. There's a whole bunch of jobs that in the past were called like deployment engineers, or like people who were managing like Hadoop clusters and stuff, but that's not really like that useful anymore, because there's like other scheduling services that are offered internally to like Azure and AWS and GCP. They have scheduling services, so you don't really need to manage that yourself. And once you set up those functions once, they just run forever, and Amazon or the whatever company that you're using on the back end, will manage that for you. Don't get me wrong though, because there's still a super need if you are getting into software engineering and you like want to get into data, like analytics is kind of where it's at. And the big idea there is you basically are the person who's going in to the data warehouse, that is wherever the data is stored. So Azure, GCP, or AWS, excuse me. And I'm more familiar more recently with dealing with GCP and Azure. But with GCP, they have a product called BigQuery, and BigQuery is like the service that sits on top of the data warehouse, or it like is the data warehouse kind of, but it's like the platform that you can use inside of GCP to query all of the data. And you query using structured query language or SQL. So in this particular case, the skill set that you would need is sort of like just reading the introductory documentation on BigQuery and how to get, whatever keys or authentication tokens that you need to be able to get into the data warehouse as whatever kind of user you are. And then you need to like query the database for whatever it is that you need. So a part of that is like starting with a question. So hopefully you have a product owner, a product manager, someone who has a question about the data. They're like, oh, I'm trying to figure out okay, let's talk about the newspaper. So the New York Times. I'm trying to figure out I want to find all the articles that will teach me how to cook steak. Okay, cool. So maybe that comes from the cooking section, right? So you need to figure out which tables are available in the cooking section. You need to figure out which columns are available in those tables that would have metadata around steak or meat, whatever other words might be indicative of you. It would help you find that information. So you could play around with SQL in BigQuery to try to figure that out, or go talk to the New York Times cooking team, the software engineering team, whoever's owning that database, and just ask them, hey, what tables are available? Write the names of those tables down and then just go look at them. So you can just like select the name of that table and then look at all the columns and then just figure out which columns could be useful for you. Maybe query the first 10 records in the table so you can see what the raw data actually looks like. Like when you query that, will you get a record that actually has the name of a type of meat, or will it just say meat? I don't know. I'm not looking at that data, so I don't know, but that's sort of like the big idea here. And then once you get that, you want to be able to, let's say you find a whole bunch of records. You find maybe like 200 records, which are articles on meats. So now you just have a table. That table is probably not going to be that useful for that product manager because there's some reason that they need that. So you need to present that information in another way. You could do that maybe by creating a PowerPoint sheet, right? A PowerPoint presentation where you have the image of the article and then a little summary of what the article says. So that could be a PowerPoint. You could just manually do that, right? Or you could create a graph of some kind that, just puts maybe like an image of the title, the text title in a box with a timeline so that you can see when the articles were written in chronological order. So like, the earliest articles are over here and the later articles, are here. And if two articles are written on the same day, then they stack. you could cluster maybe by the number of words. There's so that entire field of how to present the data is another field called the field of data visualizations, and there's like courses on that. And there's also courses on qualitative research. So the point of that is you being able to understand how to ask qualitative questions about your data set, because even though your product manager might have come with a very high level question, there's sort of like user-centered design additional questions that you could ask that could help you dive deeper into that data set to figure out what more you might want to know, and what more could help you understand the question that you're trying to answer. That still has not brought us, though, to me and meta learning. So we're going to go back here. So I was doing all of that. So we got from web development to, we didn't really talk, we brushed completely past software engineering to data engineering, but basically we went from web development to software engineering to data engineering to data analytics. Now we're kind of moving to data science, which is more about the data collection. So sometimes you might actually need to create a new funnel where you are producing new data